Okay, good afternoon. I've had a couple of questions about doing operations with scientific notation. So I just, obviously you can see up here that I took Michaela's sheet that she had yesterday, and I just downloaded it so that way I could show you how to complete operations with scientific notation. Before we begin, remember, when you multiply any two numbers with the same base, you add their exponents, okay? So for scientific notation, if you had 10 to the third times 10 to the fifth, that would equal 10 to the eighth, okay? So that's the first thing that we have to remember. And conversely, anytime that you divide numbers with the same base, you subtract their exponents. So 10 to the eighth divided by 10 to the fourth equals 10 to the fourth. Okay? All right. So I will be using a calculator as we go along because I only have so much time to record on Screencastify. But you'll see that the calculator I will be using, it's not going to cheat. I'm still going to be using all the same steps that you would use, and really that's all I care about is that you just understand how to use these steps. Okay? To do this, any calculator will work, including your cell phone calculator, if that's all that's available to you. I know at home, we're not going to go out and buy a calculator at Staples if they're even open at this point. So, if we are multiplying or dividing numbers in scientific notation, the first thing you're going to do is we're using the commutative property to be able to multiply in any order, right? So for number one, just to explain that, you have 3.4 times 10 squared times 4.8 times 10 to the sixth. Now, multiplication can be done in any order if all we have is multiplication. So that's what we're going to do here, okay? So first, we're going to multiply or divide our rational numbers. In that case, that's our 3.4 and 4.8. So first, we're going to do 3.4 times 4.8. Okay, and I'm doing the best I can with writing. Obviously, that one wasn't that great, but you understand what I'm doing. So 3.4 times 4.8 equals 16.32. Okay, then we're going to multiply our 10 powers. So we're going to do 10 squared times 10 to the sixth. Now that's why we went over, they have the same base. So if we're multiplying 10 squared times 10 to the sixth, we're going to add those exponents together, and it's going to get 10 to the eighth. Okay? Now what's great about this is that's actually our answer here. So our answer is 16.32 times 10 to the eighth. And you notice that appears to be what scientific notation looks like, except for the fact that we're not allowed to have two digits after or before the decimal point, right? We can only have one digit after the before the decimal point. So we're going to move this decimal so that way we have 1.632. But obviously, we just divided this by 10 to go from 16.32 to 1.632. That's supposed to be a 3. So if we divided this by 10, it'll even out if we multiply one more 10 on this one. So if we multiply by one more 10, now we've got 10 to the ninth. Okay? And that is our answer for problem number 1. Okay? For problem number 2, the steps are all the same, just with the, you just have to remember that with division, instead of adding your exponents, you're going to subtract your exponents. So first we're going to do 7.56 divided by 3.15. And again, this is where I'm using my calculator. 7.56 divided by 3.15 equals 2.4. So they did that nicely. It's 2.4. And then we have 10 to the eighth divided by 10 to the third, which equals 10 to the fifth. And now what's great is we have 2.4 times 10 to the fifth, and that is in scientific notation, so that's our answer. Okay? All right. The next one, again, just to be really quickly, I'm going to completely cheat, and I'm just going to show you if this were 4 and 8, we would have 32, which obviously that's not, it's 4.62 times 8, it's going to be higher than that, but I'm just doing 4 times 8 is 32. This is completely just an estimate, and then 10 to the 5th times 10 to the 9th would be 10, that's a times, 10 to the 14th, and we can't have 32, so we're going to make that 3.2 times 10, and since we made this smaller, we'll make this bigger, so 10 to the 15th. Okay? And then, again, for this one, we'll, I won't cheat completely, I might as well do it. 2.56, 567 divided by 5.23, and we get, oh my goodness, 0.49082218, whatever, it doesn't matter. We're going to do 0.49, and then 10 to the negative 9th divided by 10 to the negative 3rd. Remember, we're going to subtract. So negative 9 minus negative 3 is the same as negative 9 plus 3, because we keep change, and we wind up getting negative 6. So it's times 10 to the negative 6th. Now again, this time we have to make this 1/10 power larger. So it's 4.9. So essentially we had to multiply this by 10, which means we have to divide this by 10 or make this 1/10 power smaller. Well, one number smaller than negative 6 is negative 7. So there's your answer there. It's 4.9 times 10 to the negative 7th, okay? Now, when we're adding or subtracting for scientific notation, the hard work is done before we start to do the math, okay? So we've got to do the hard work first, which means just like fractions, the hard work is done before you start to add or subtract fractions. It's the same thing with scientific notation. We need to have the same 10 power, okay? Just like fractions need the same denominator, we need the same 10 power when it comes to scientific notation. Now you'll see in number 1, they don't have the same 10 power. Now I try to tell students it's always easier, well, not always, but 99% of the time it's easier when adding or subtracting to make the smaller 10 power into the larger 10 power, okay? So I'm going to turn this one into a 10 to the 4th. But in order to make this 10 to the 4th, I raise this 1/10 power, which means I have to lower the rational number 1 to balance out. So if I raise this a power of 10, to lower this a power of 10 means divided by 10. So this becomes 0.545 times 10 to the 4th. And then this is still 3.12 times 10 to the 4th. Now we have the same 10 power. Now we're allowed to start doing operations, which it's just addition. You just add your 2 rational numbers here. So 0.545 plus 3.12 equals 3.665. And then we keep the power of 10. Just like in fractions, we would keep the denominator once we make it the same. We do the same thing here. We just keep our power of 10. Now, if I had not changed this to the larger and I had changed it to the smaller, would we have an issue? The answer is yes and no. You would still get the same answer. The problem is you would wind up getting 0.3665 times 10 to the 3rd, which you'd then, or I'm sorry, you'd get 36.65 times 10 to the 3rd, which we would have to make into 3.665 times 10 to the 4th. So we wouldn't be in scientific notation. And like I said, 90+% of the time, this is the easier way to go, okay? So here on number 2, we notice that now we have a negative. Well, the one thing you have to remember is if we want to change the smaller 10 power to the larger, which is the smaller 10 power? The answer is not -5. The answer is -6 is the smaller 10 power. Remember, -6 is smaller than -5. So I'm going to turn this into a 10 to the -5th. Well, in order to do that, I had to multiply this by a power of 10, which means to offset that, I have to divide this by a power of 10. So this becomes 0.42 times 10 to the negative fifth. And this is 2.67 times 10 to the negative fifth. And we're subtracting these. So 2.67 minus 0.42 equals 2.25. And then we would have times our common 10 power, 10 to the negative fifth. Okay? All right. Again, if you had changed the negative 5 into a negative 6, that would have been fine. But this would have been 26.7 times 10 to the negative 6. And you notice if you did 26.7 minus 4.2, you'd get 22.5, but it would be 22.5 times 10 to the negative 6, which is not in scientific notation. Most of the time, you change the smaller 10 power into the larger one, and you're going to be fine in the end without having to do anything. Okay? So you've got to remember that. Now, these last two, the only difference between these is now we have to change it twice, but that's okay because the more we change this smaller 10 power, the less significant it becomes. It's just going to change our answer less and less and less. So if we want to make this a 10 to the 7th, we would have to up this by 2 powers of 10. So we'd have to make this offset by lowering this number by 2 powers of 10. So by lower it by 1 power of 10, it becomes 0.625. Lowered by 2 powers of 10 becomes 0.0625. And this is 1.7 times 10 to the 7th. Now you notice how I said this is less significant because 0.0625 is not going to change much when I add it to 1.7. In fact, this is now just going to become 1.7625, didn't need a calculator for that, times 10 to the 7th. Okay? All right, the last one, I will do it really quickly. I've got about 2 minutes left. I will do the last one really quickly, going what would be quote-unquote the wrong way. I'm going to change this to the 10 to the 9th power. I went the way I said don't go. But since I lowered this by 2 powers of 10, I have to increase the rational number by 2 powers of 10, which means this would now be 284 times 10 to the 9th. Minus, this is what you get when you're looking at the clock, 5.4 times 10 to the 9th. You notice I've got the same 10 power, so I go ahead and I subtract. 284 minus 5.4 equals 278.6 times 10 to the 9th. We don't have the wrong answer here, we just don't have it in scientific notation. So I have to move this decimal twice to make it 2.786, but since I made this 2 10 powers smaller, I'm going to offset that by making this 2 10 powers larger, and this is times 10 to the 11th. You notice that if I had just changed this to a 10 to the 11th, I probably would have gotten the same answer. The answer is yes, I absolutely would have gotten the same answer from the very beginning, but I wouldn't have had to change the scientific notation when I'm done. Okay? I hope that this clears things up. I hope that this helps. I hope that you have a great weekend, and I will talk to you next week. All right? Have a great weekend.